Hey there guys, Paul here from theengineeringmindset.com. In this video, we're going to be looking at Ohm's law to understand how it works as well as how to use it. There are also two problems at the end of this video for you to test your knowledge and see if you can solve. So what is Ohm's law? Ohm's law is the relationship between voltage, current and resistance and how they relate to each other. Ohm's law was developed by a German physicist named George Ohm, who undertook many experiments to develop his theory, including measuring current by touching live electrical circuits to see how much it hurt. As you might imagine, the higher the current, the more it hurt. Now there are three formulas we need to use for Ohm's law, but we don't actually need to remember these, and I'll show you a super easy tip in just a moment. So the three formulas we use for Ohm's law are voltage equals current multiplied by resistance, current equals voltage divided by resistance, and resistance equals voltage divided by current. If that seems like a lot to remember, then don't worry, because we don't need to remember them. All you need to remember is Ohm's triangle, which looks like this. So you just need to remember these three letters in order, V, I, R. Then we just write those letters in a triangle with V at the top, and we draw a line to separate the letters. In fact, you don't even need to remember those because I've made a free PDF guide for you with some worked examples which you can keep on your PC or your mobile and access wherever you need. Links for that can be found in the video description down below. Now all we do when we need to use a formula is cover up the letter we need. So if we want to find the voltage, then we write V equals, and then we cover up the V in the triangle. That leaves us with I and R. So we write I multiplied by R, which means voltage equals current multiplied by resistance. You can write a little multiplication symbol in the triangle between the two letters if it helps you. Now I know what you're thinking, why is current represented with the letter I and not a C for current, or even a letter A for the unit of ampere? Well, the unit of current is the ampere or the amp, and this is named after André Ampère, a French physicist. A couple of hundred years ago, he undertook lots of experiments, many involved varying the amount of electrical current. So he called this intensity du current, or the intensity of current. So when he published his work, they took the letter I and it became standard until this day. Now you might also come across formulas where the letter E is used instead of V. The letter E stands for EMF, or electromotive force, but don't worry about that. Just stick to using V and substitute V for E if you see it used in Ohm's law questions. Anyway, so by covering V, we get voltage equals current multiplied by resistance. If we want to find current, then we write down I equals, and then we cover up the letter I in the triangle. That gives us V and R. So as V is above the R like a fraction, we can write V divided by R. Therefore, current is equal to voltage divided by resistance. If we want to find resistance, then we write down R equals, and then we cover up R in the triangle. That leaves us with V and I, so we write V divided by I, which gives us resistance equals voltage divided by current. Let's look at some examples for how to use these formulas. First, let's see how we find voltage and how it relates to the other parts. Let's say we have a simple electrical circuit with a battery and a resistor. We don't know what the voltage of the battery is though. The resistor is 3 ohms, and when we connect a multimeter into the circuit, we see that we get a reading of 2 amps of current. We want to find the voltage, so using Ohm's triangle, we can cover up the V, and that gives us V equals I multiplied by R. We know the current is 2 amps, so we can write that in, and we know the resistance is 3 ohms, so we can write that in also. Therefore, 2 amps multiplied by 3 ohms gives us 6 volts. The battery is therefore 6 volts. Now if you want to check your answers for Ohm's questions, then I've built a free calculator on the website. You can just drop your numbers in and it will do the calculation for you. Links for that again in the video description down below. Coming back to the circuit, if we now double the voltage by connecting two 6-volt batteries in series, we get 12 volts. If we now connect this to the same circuit, the current also doubles from 2 amps to 4 amps. If we double the voltage again to 24 volts, the current will also double to 8 amps. So what's the relationship here? We can see that current is therefore directly proportional to voltage. If we double the voltage, we double the current. Remember, voltage is like pressure, is the pushing force in the circuit. It pushes the electrons around the wires, and we place things like lamps in the way of these electrons so that they have to flow through these, and that causes the lamp to light up. By doubling the voltage, we see that the current also doubles, meaning that more electrons are flowing, and this occurs as we apply more pressure or more voltage. This is just like if we were to use a bigger water pump, then more water will flow. Okay, so what about finding current? Let's say we now have a 3 ohm lamp connected to a 6 volt power supply. To find the current, we write down I equals, and then we cover up I in the triangle. That gives us V divided by R, so current equals voltage divided by resistance. We know the voltage is 6 volts and the resistance is 3 ohms, so the current is therefore 2 amps, and that's what we see on the multimeter. By the way, if you don't have a multimeter, then I highly recommend you get one. It's essential for troubleshooting, but also building your essential electrical knowledge. I'll leave some links down below for which one to get and from where. So we saw what happens when we use a resistance of 3 ohms in the circuit. But if we double the resistance to 6 ohms by placing another 3 ohm lamp into the circuit, the current halves to just 1 amp. If we double the resistance again to 12 ohms, the current will halve again to 0.5 amps. We can visually see this because the lamps will become less bright as the current reduces from the increase in resistance. So what's the relationship here? We can see that the current is inversely proportional to the resistance. When we double the resistance, the current will decrease by half. If we halve the resistance, the current will double. Current is the flow of electrons, or the flow of free electrons. For us to make this lamp shine, we need to push electrons through it. How do we do that? We apply a voltage across the two ends. The voltage will push the electrons. The atoms inside the copper wire have free electrons in their valence shell, which means they can very easily move to other copper atoms. They will naturally move to other atoms by themselves, but this will be in random directions, which is of no use to us. For the lamp to turn on, we need lots of electrons to flow in the same direction. When we connect a voltage source, we use the pressure of the battery to push the electrons through the circuit all in the same direction. For example, to power this 1.5 ohm resistive lamp with a 1.5 volt battery requires 1 amp of current. This is equal to 6,242 quadrillion electrons passing from the battery and through the lamp every second. And if it can achieve this, then the lamp will stay at full brightness. If the voltage or current reduces or the resistance of the circuit increases, then the lamp will become dimmer. Okay, now let's look at finding resistance. Say we have a resistive lamp connected to a 12 volt power supply. We don't know how much resistance is adding to the circuit, but we measure the current as 0.5 amps. To find the resistance, we write down R equals, and then we cover up the R in the triangle. We're left with V and I, so resistance equals voltage divided by current. We know the voltage is 12 volts and the current is 0.5 amps, so 12 divided by 0.5 gives us 24 ohms of resistance. Resistance is the opposition to the flow of electrons. It tries to prevent electrons from flowing. That's why we use resistors in circuits to reduce the current and protect components such as an LED. If we try to connect an LED directly to a 9 volt battery, it will blow out because the voltage and the current are too high. But when we add a resistor into the circuit, then these are reduced, so the LED is protected and will shine brightly. So given the circuit, we can increase the current by increasing the voltage, or we can also increase the current by reducing the resistance. We can also reduce the current by increasing the resistance. Okay, time for you to test your skills. Can you solve these problems? I'll leave a link for the answer and the solution in the video description down below. Problem 1. Let's say we have this lamp which has a resistance of 240 ohms. If we plug this into an outlet in the US, which uses 120 volts, what will the current be? Problem 2. If I plug the same 240 ohm resistive lamp into an outlet in the UK, we get a current of 0.958 amps. So what is the voltage being applied here? Okay guys, that's it for this video, but to continue your learning, then check out one of the videos on screen now and I'll catch you there for the next lesson. Don't forget to follow us on Facebook, Twitter, Instagram, LinkedIn, as well as theengineeringmindset.com.